My name is Bernardo Garcia Morones, and my topic is what happens when cold and hot particles collide with each other. So, I think that this experiment could help us to understand the motion and the objects that take shape after particles collide with each other. When this collision happens, many things can actually result after the collision. For example, the temperatures can combine, or the kinetic energy will be stable, or one object will take the other's temperature. There are many things that could happen in this experiment. I think that understanding how a hot particle helps to take an object's shape. For example, a hot particle will be more expanded while a cold particle will be contracted. So understanding this kind of collision could help us give us a further knowledge of the object's shape and collisions. So my theoretical framework is that temperature on a particle allows us to measure kinetic energy. Thermal energy allows us to measure the total kinetic energy of the particle substance. The greater motion of the particle, the greater the temperature, the greater the kinetic energy. In this experiment, I'll be also using the kinetic energy formula, which is mass times velocity squared divided by 2. My control variables are size, number, and the mass of the particles, both. Dependent variable will be the velocity and the kinetic energy that results after they collide with each other. My independent variable will be temperature, which affects if the hotter the temperature, the higher speed, and the lower the temperature, the lower the speed. So I'll be using the timer that helps me to keep track of how much that the particles have collided with each other. I'll be taking mass and the velocity, and also the cold particle is the blue one, which is gonna be moving slow, and the hot one is gonna be the pink particle. Both masses will have 1 kilogram, and the initial particle of the cold one, which is the blue one again, is gonna be 0.5 meters per second to the right, and the pink one, which is the hot one, will be negative 3 meters per second to the left. So the first time when the experiment is launched, there's no collision. So the particle would be 0.5 meters per second to the right, and the hot wall would be 3 meters per second. The kinetic energy using the formula of mass times velocity squared divided by 2 results in 1/8 of a joule, and the hot one will be 9/2 of a joule. Summing them up, which is just adding them up, is gonna be 37 halves eighths of a joule. I'm sorry. So something interesting happened in this experiment. I saw that the first collision, the cold particle took the hot particle's speed, and vice versa. The hot particle took the cold one, and it happened. It switched the speeds. So I can see that the kinetic energy was also switched, but the total kinetic energy stayed the same. Here in the graphs, we can see how the cold particle started slow, and then it went up, down, and the same one for the hot one. Then here are the proofs of my experiment, which we can see in the first one that the cold particle is moving slow and the hot one really fast. We can see after the first collision, the hot particle is gonna be moving slower and the cold particle really fast. And you can see this goes all around the experiment. So, for conclusions, first of all, I saw that kinetic energy was conserved. And this is true because this type of collision was inelastic, which means that the total loss of kinetic energy is equal to 0. Also, the theoretical framework stated that the higher the speed, the higher the kinetic energy, which also was true, since the mass is the same, but the initial velocity was 0.5 on the cold one and 3 on the hot one, so the kinetic energy was gonna be higher. Then, um, then if the kinetic energy is higher, it means the temperature will also be higher, resulting in different temperatures. My hypothesis was incorrect. First of all, I thought that the object's collision would combine. For example, uh, I don't know how in my head worked, but let's suppose that it was at 300 Celsius and 5 Celsius degrees. They combine, so it would make 305 Celsius and divided by 2, and that would be the equal amount of temperature for both of them. But they will be moving in the temperature that had the highest velocity, or in this case, the force. And thanks to this simulator, I had no issues at all. But another thing that I saw that was kind of curious during while I was doing this experiment was that I could make different positions. For example, what if the particle touched the corner, it would behave in a different way. But that would ruin the project since or the experiment since the results will be variable and I have no way to measure that. This is my bibliography and thank you so much.